Now, with this in our mind, then we'll do some example. This example says that find the nth term of and the 5th term and the 10th term of the arithmetic sequences. Arithmetic sequence. We are given natural log 3, natural log 9, natural log 27, natural log 81. And we were told this is arithmetic sequence. Is this arithmetic sequence? It is actually. How is the arithmetic sequences defined? Is this term minus the previous term is a constant. Okay? Is this a constant? It's actually, it is. Look. A2 minus A1 is natural log 9 minus natural log 3. It's a subtraction, so here is actually 9 minus 3. Okay? 9 divided by 3. You know the subtraction can be changed to the division. And then you see that's natural log 3. The third term minus the second term is natural log 27 minus natural log 9. Okay? 27 divided by 9 is natural log 3. So you see the difference is a constant, natural log 3. How about the fourth one minus the third one? Remember, it's always the one here minus the front. Okay? Don't switch the order. Yeah, it's always this term minus the previous term. So natural log 81 minus natural log 27. Change the subtraction to division. 81 divided by 27 is natural log 3. So it is a arithmetic sequence. Okay? So, and the difference right here is natural log 3 is the D. All right. Now, based on the formula, we know the first term, then here is natural log 3. The nth term then equals what? Natural log 3 is the first term, so you want to put is, here we know D already. D is natural log 3. And then A sub n is the first term, natural log 3, first term, times n minus 1 times the difference. Difference is natural log 3. Okay? In this case, the difference is actually also equal to the first term. It may not be equal. Okay? We see from previous example. Previous example, the initial term was 2, the difference was 4. In this case, the first term is natural log 3, but the difference is also natural log 3. Okay? So n times natural log 3 minus 1 times natural log 3. And you have a positive, negative cancel each other, so the nth term is 10 times natural log 3. Okay? Now, how about 10th term? Okay? How about 10th term? 10th term is right here. N is 10. N is 10. N is 10, then you will have a term, a sub 10 is 10 times natural log 3. What is this number? It's really the coefficient in front of natural log can be moved to the top, to the top of 3. Can be 10. The coefficient here moved up is actually the exponent of 3. And you know 3 to the 10th is this number. How to calculate that? 3 to the 10th is not 3 times 10. It's not 30. It's actually 3 times 3 times 3, 10 times. In the calculator, you do it in this way. 3, 2. Here is the 2 tenth. So 59,049. Okay. Yeah. I did here for the 10th 10. You may find out what? You may find out 5th 10. Okay. The 5th 10 down here is a to the 5th. Here we also need 5th 10, right? Yeah. So then you have 5 natural log 3. Okay. That equals natural log 3 to the 5th. Remember that's, you do the same way. Okay. Then you will have a 3 to the 5th. That's 243. 243. So you have a natural log 243. It's not 243 is not really half of that. So remember. So if you divide that, you won't get that. That's different. Okay. So this is one application. This arithmetic sequence looks quite different. Looks quite different. And here we actually find out a general formula. This is the formula for all arithmetic sequences. And then for the special case, a sub n can be like that. Okay. For each individual arithmetic sequence, and you will get different formula. But in general, this is true. Again, the nth term is the initial term plus, if here is n, so n minus 1. Always 1 less than the sub-index n, and then times the difference. Okay? Now, let's look at another example. Another example is that we are given a 4, the 4th term, and the 11th term. The 4th term is 10, the 11th term is 52. We want to find out common differences for the arithmetic sequence and with the specified terms, those two terms. So in this case, the common differences is what? In this formula is asked us to find D. Okay? And we were also told is an arithmetic sequence. So then this formula applies. Okay? This is the general formula to find out nth term. So this formula applies. Okay? Now, since this formula applies, we may first step write it out. That's the technique. Don't try to think. Try to write it out to help you to think. That's a very good way to do it. Write things then help us to think. And then here is 4, 4th term. So then you plug in 4 here. You plug in 4 here. Then here is 4. Then here is 4 minus 1. So it's 3. But we know a sub 4 is 10. And we also know, we plug in 4 here. We plug in 10 here. Since a 4 is given, it's 10. So then you have a 10 equals a 1 plus 3D. Okay? Yeah. Similarly, if you plug in 11 here, and here will be 11 minus 1, that will be 10. Okay, so that's the following one. If you have a A11, then A11 equals the initial term plus 11 minus 1 times D. And then we know A sub 11 is 52. Okay, 52. And then A1 plus 11 minus 1 is 10D. Here we have a D, so you copy it. this looks like a linear equation. Okay, so that's why we have intermediate algebra or introductory algebra. Using that method, we can find out d, and the first term we can also find out. But here we were not asked to find out the first term. We can, but we just need to find out the differences. To find out the difference is we use the second one minus the first one. You see 52 minus 10, we then have 42. A1 minus A1, they cancel each other. And 10D minus 3D, we have a 7D. Okay? So you have 42 equals 7D. And both sides divided by D. You cancel 7 with 7. Right-hand side, we have a D. Left-hand side is 42 divided by 7 is 6. So the common difference is actually 6 in this case. Okay. Now, this one is try yourself. Okay. Find A1 given what? Given A8 is 49 and A9 is 55. Of course, you can solve this one based on the way I did. Actually, I did is like this. You see? Yeah, it's like this. The same pattern as I did to find out D first. And then, moreover, you see down here, you can find out the first term because ask you to find out A1. And then, after you find out D, you may go back to find out A1. Here, we may use a different way to do that, is that we know A8 and A9, one is 49, one is 55. Those two terms, this guy follows that. So we know that 55 minus 49 will give us the D. Okay, so we don't have to solve D in this complicated way. We can find out D right away from here. 55 minus 49, which gives us D quickly, because those two numbers, the two terms are very special. A9 follows A8. Okay, so D can be easily found. All right, if we find out D, then it will be easier. Why? You look at A8, that equals A1 plus 7D. A8 we know, which is 49, 49. And then D we know is 6. So 6 times D is 42. So in this case, it's easy to solve A1. 49 plus A1 equals A1 plus 42. Then apparently A1 has to be 7. 7 plus 42 is 49. Okay, you try yourself. Actually, I did it for you. Okay. I want you to think over about this one. All right. So, in this lecture, the most important thing is the concept of arithmetic sequence and this general formula and how we are going to apply it. This general formula says that for the nth term is always the initial term plus, and then you have a n minus 1. Here is n, here is n minus 1. This number is always one less than the previous one, times d. Okay, 3, 4, 5. All right, so I'll see you next time.